Welcome to the session on Amazon Web Services. In this session, we'll discuss about Amazon Storage Services. Earlier, we had discussed about Amazon Storage Services in session 1 of Module 2. Here, we will discuss in detail and perform lab on storage offerings by Amazon Web Services. So let's begin with the agenda. Here, we will discuss about AWS Storage Services, storage options, Amazon S3 services, its component operations. Further, what are storage tiers, classes, and how acceleration transfer works? What is the usage pattern, storage classes, and client to S3 bucket, which we will understand with the help of an example. We'll talk about object tags, how to host a website, how SQL queries are performed. We will also have an introduction to Amazon Glacier and Amazon EBS. We will discuss about Redshift Spectrum and how it works. At the end of the session, we'll have a detailed lab session. So let's begin with storage services by Amazon. Amazon S3 provides comprehensive security and compliance capabilities that meet even the most stringent regulatory requirements. Let's begin with the Amazon S3, which is an object storage, which is built to store and retrieve any amount of data from anywhere, websites, mobile apps, corporate applications, and data from IoT sensors or devices. It is designed to deliver 99.99999% durability. Amazon S3 provides flexibility to customers in the way they manage data for cost optimization, access control, and compliance. S3 provides query in place functionality, allowing you to run powerful analytics directly on your data at rest in S3. All these tasks are accomplished by using AWS Management Console, which is simple and intuitive web interface. This session is an introduction to Amazon S3 and how to use AWS Management Console to complete the tasks. Amazon Simple Storage Service S3 is a storage for the internet. It is specifically designed to make web-scale computing easier for developers. Also, a user can use S3 programmatically by using SOAP or REST protocols. Hence, can use various development toolkits with S3 with the help of these protocols. Here, figure clearly shows a client using REST API to connect to S3 object and uses it according to their need. The underlying concept of Amazon S3 is it stores data as objects within buckets. Now, in order to store an object in Amazon S3, file is uploaded to the container for objects called bucket, and permissions are set on the object as well as any metadata. Each object in the bucket is uniquely identified by its key and version ID, as every object in a bucket has exactly one key. User can define the geographical region in Amazon to store the buckets created. Regions are chosen carefully so that it optimizes latency, minimizes cost, and takes care of address regulatory requirements. Now, importantly, Amazon S3 provides read after write consistency for puts of new objects in your S3 bucket in all regions with one caveat. The caveat is that if you make a head or get request to the key name before creating the object, Amazon S3 provides eventual consistency for read after write. We will understand this little later. Amazon S3 offers eventual consistency for overwrite, puts, and deletes in all regions. Amazon S3 basically has three key components, namely objects, buckets, and keys. Here, objects can be defined as a fundamental entities or information which is stored in Amazon S3 and consists of object data and metadata. The data portion is opaque to Amazon S3. The metadata is a set of name-value pairs that describe the object. These include some default metadata such as data last modified and standard HTTP metadata such as content type. Here, user can also specify custom metadata at the time the object is stored. An object is uniquely identified within a bucket by a key name and version ID. Another key component, bucket, which is a container for objects stored in Amazon S3. Every object is contained in a bucket. Buckets are owned by AWS account. Suppose if we have a file called hello.png that is stored in S3 buckets, then the URL of the file will be the link shown on the screen. These buckets serve several purposes. They organize the Amazon S3 namespace at the highest level. They identify the account responsible for storage and data transfer charges. They play a role in access control, and they serve as a unit of aggregation for usage reporting. These points will be much more clearer when we will do lab. Key in Amazon S3 is the unique identifier for an object within the bucket. Every object in a bucket has exactly one key because the combination of a bucket key and version ID uniquely identify each object. So Amazon S3 can be thought of as a basic data map between bucket key version and the object itself. How does an Amazon S3 operates? This is a very basic for everyone to understand. Sign in to get into AWS. SOAP or REST APIs are also used to connect to S3 buckets and perform various tasks like creating a bucket, writing an object, whereas the object can be any type of file. It can be a text, image, video or any other format. Permission is required from S3 to read a file from a third-party API. See, S3 provides 4-tier storage or classes. S3 is the basic class of storage. By default, your file is stored into S3 buckets and it has 99.9 point availability and 11 times 9 durability. Stored redundancy across multiple devices in multiple facilities and is designed to sustain the loss of 2 facilities concurrently. If you use any object very regularly, it is advised to store it in S3 bucket. It is very easy in retrieval. Whereas another service S3 infrequently accessed, that is IA, is used for data which is accessed infrequently but requires a rapid access when needed. It has lower fee than S3 but you are charged a retrieval fee. It is used when you need some files very rarely but you need to retrieve it very fast. Then S3 IA is used. Another option which is available is reduced redundancy storage and is designed to provide 99.99 durability and 99.99 availability of objects over a given year. The reduced redundancy storage RRS storage class is designed for non-critical reproducible data stored at lower levels of redundancy than the standard storage classes. And lastly, Glaciers, a storage class which is suitable for archiving data where data access is infrequent. Archive objects are not available for real-time access. You must first restore the objects before you can access them. The Glacier storage class uses the very low cost Amazon Glacier storage service, but you still manage objects in this storage class through Amazon S3. Further to our discussion is transfer acceleration. What is it? It enables fast, easy and secure transfer of all files over long distances between your client and an S3 bucket. Transfer acceleration takes advantage of Amazon CloudFront's globally distributed edge location. For understanding edge locations, please check our session 1 of module 1. As the data arrives at the edge location, data is routed to Amazon S3 over an optimized network path. When using transfer acceleration, additional data transfer charges may apply. To understand it better, suppose we have an S3 bucket which is in India and we have users across the world. Now they want to access the bucket. So depending on the physical location, latency will be different and different latency time will be required to write to the bucket. In order to solve this problem, we have edge locations around the globe. The file will be written to the edge location nearest to the user. Then the edge location will write the file to the bucket. By this way, the file is written or read in accelerated way like CDN. If you remember in session 1. You can check the acceleration speed of different availability zones across the globe by running Amazon S3 Transfer Acceleration Speed Comparison tool by visiting the URL which is shown on your screen. Here you can compare your upload speed with your other availability zones. You can run this tool. It will upload a sample file to all the regions to check their speed. It will be compared standard speed with accelerated uploaded speed. Remember, while using accelerated transfer, you may be charged extra for using it. Since storage is the most useful, it is important to understand Amazon S3 usage pattern. Till now, we had discussed that S3 is a service to store your data or file on the internet. Whenever a file is uploaded in a bucket, a unique key is generated and the same key is used while retrieving data, and S3 stores it, analyzes and then retrieves the file. Amazon S3 offers a range of storage classes designed for different use cases. These include Amazon S3 Standard for general purpose storage of frequently accessed data, Amazon S3 Standard Infrequent Access for long-lived but less frequently accessed data, and Amazon Glacier for long-term archive. Amazon S3 also offers configurable lifecycle policies for managing your data throughout its lifecycle. Once a policy is set, your data will automatically migrate to the most appropriate storage class without any changes to your applications. Here, look at the example on your screen in which client connects to S3 buckets. Client request for the bucket. As you have seen, the bucket or a file address is in URL. So the request will be sent to Route 53. Route 53 will resolve the address requested and through HTTP put or post it will send it to the edge location of the bucket. Edge location will resolve the request and connect it to the S3 bucket and cache the data into its table. Then edge location will send back the request to the client. To upload large object in parts, multiple part upload API is enabled. You can use this API to upload new large objects or make a copy of an existing object. Multiple part uploading is a 3-step process. You initiate the upload, you upload the object parts, and after you've uploaded all the parts, you complete the multiple part upload. Upon receiving the complete multi-part upload request, Amazon S3 constructs the object from the uploaded parts, and then you can access the objects just as you would have any other object in your bucket. See, if you are uploading the file using AWS SDK, then it will automatically switch to multi-part transfer when the file is over specific size threshold. You can upload or download files in parallel. It gives the progress callback to monitor transfer, and if it fails, it retries again. By default, S3 buckets are private, which prevents any unauthorized access to its content. If you want to implement some additional best practices in order to ensure integrity of your data, you can. To further secure your data, you can add permissions on your S3 buckets. Basically, use bucket level or object level permissions alongside IAM policies to protect resources from unauthorized access and to prevent information disclosure, data integrity compromise, or deletion. Another is implement versioning of all objects. It is recommended to enable versioning to store a new version for every modified or deleted object from which you can restore compromised objects if necessary. You should backup your data. You can backup data stored in Amazon S3 to other Amazon region or to on-premises backup systems. Last important is use server-side encryption for your data. Access control lists are actually another option. They are fine-grained controls that are rarely used, where customers specify which users are permitted access to the buckets. It is a good security practice, and these ACLs only allow specific authorized internal users to have access to the data in the bucket. ACLs for your Amazon S3 bucket are as restrictive as possible, especially those that contain highly sensitive enterprise data. Only authorized internal users should have an access to the buckets. Further to Amazon S3 object tags, they are key value pairs applied to S3 objects, which can be created, updated, or deleted anytime during the lifetime of the object. You may use object tags to store object-specific metadata in a key value form. You may also use object tags to create IAM policies, set up S3 lifecycle policies, and customize storage metrics. You can configure tag-based object transitions between storage classes and expire objects in the background. With S3 browser, you can easily manage object tags from a simple user interface. AWS S3 allows you to tag your objects so that if you forget the file or object name, you will be able to find your file based on a tag. You can add 10 tags per object. All these things we'll see in our lab session. Now let's understand how can we host our static website on S3. You can host a static website on Amazon Simple Storage Service. On a static website, individual web pages include static content. They might also contain client-side scripts. By contrast, a dynamic website relies on a server-side processing, including server-side scripts such as PHP, JSP, ASP.NET. Amazon S3 does not support server-side scripting. Amazon Web Services also has resources for hosting dynamic websites. To host a static website, you configure an Amazon S3 bucket for website hosting. Then upload your website content to the bucket. The website is then available at AWS region-specific website endpoint of the bucket. Instead of accessing the website by using an Amazon S3 website endpoint, you can use your own domain such as example.com to serve your content. Amazon S3 along with Amazon Route 53 supports hosting a website at the root domain. You can use the steps shown on the screen as well as for hosting your static website on S3. Now let's understand SQL query on S3, how to perform it. For this purpose, AWS provides another service called AWS Athena. Athena is new serverless query service that makes it easy to analyze large amount of data stored in Amazon S3 using standard SQL. You simply point Athena at some data stored in Amazon Simple Storage Service. Identify your field, run your queries, and get the result in seconds. Athena is based on Presto distributed SQL engine and can query data in many different formats including JSON, CSV, log files, text with custom delimiters, Apache Parquet and Apache ORC. You can run your queries from AWS Management Console or from a SQL client or such as SQL Workbench, and can use Amazon QuickSight to visualize your data. You also can download and use the Athena JDBC driver and run queries from your favorite business intelligence tool. Hope you are finding the session interesting. Let's further move to Amazon Redshift. Amazon Redshift Spectrum enables you to run Amazon Redshift SQL queries against exabytes of data in Amazon S3. With Redshift Spectrum, you can extend the analytic power of Amazon Redshift beyond data stores on local disk in your data warehouse to query vast amount of unstructured data in your Amazon S3, commonly called as data lake. Here the key features of Redshift are: start querying instantly, same SQL, same business intelligence tool, no loading is required. With Amazon Redshift Spectrum, you can start query on your data in Amazon S3 immediately with no loading or transformation required. Fast performance, leverage the powerful Amazon Redshift Query Optimizer. Amazon Redshift delivers super fast performance whether it is for doc analysis or large unstructured data sets in Amazon S3 or frequent analysis on structured data sets in Redshift tables. It has limitless scalability, separate compute and storage. With Amazon Redshift Spectrum, you don't have to worry about scaling your cluster. It lets you separate storage, compute, allowing you to scale each independently, and you pay as per query. With Amazon Redshift Spectrum, user pay for the queries you run. You are charged $5 per terabyte of data processed to execute your query, which you should check with Amazon again, because prices are all subject to change. Redshift Spectrum can query compressed data too. Now let's see how does it work. S3 stores data on Amazon's distributed system containing multiple servers within Amazon data center location. Data takes time to propagate. Normally propagate time is 3 to 24 hours but can available within minutes. Amazon doesn't offer you a GUI based tool to access your data. You can only use one of the several tools online and build one through API. Now let's understand where to use Athena and where to use Redshift Spectrum. Athena should be used to run ad hoc queries on Amazon S3 datasets using ANSI SQL. It can be processed structured and unstructured and semi-structured data formats. It can also be integrated with business intelligence tools or SQL clients using JDBC or with QuickSight for easy visualization. Whereas it is recommended to use Redshift on large sets of structured data. It is scalable enough that even if a new nodes are added to the cluster, it can be easily accommodated with few configuration changes. As it contains a number of replicas, even if any node is down, it interacts with other nodes and rebuilds the drive. Redshift can be integrated with Tableau, Informatica, MicroStrategy, SAS, and other business intelligence tools. It can also be used for log analysis, clickstream events, and real-time data set. So this was all about the theoretical part of Amazon storage services, and let's move forward and work on the lab. Moving forward to lab session.
Log in to AWS Console with your ID and password. Once you log in, you will see service drop down on your screen. You can see regions on the top of the page. Currently it is selected as SEAL. Now go to Services and select S3 service from the service list. You will notice that when you selected S3, the region is changed to global. That means S3 service is a global service and it should be unique in name, like a DNS name. You can see a dashboard to create a bucket. Here bucket means a fodder to keep your data. Give a unique name to your bucket. There should not be any duplicacy. Then select region for bucket to be placed. I am in India, so I will select Mumbai region. Then you have to copy settings of any pre-existing bucket. Currently I have no bucket, so I will leave it blank and hit next to move further. In the next setting you will be asked to provide properties to your bucket. You can see the properties icon on your screen. You can make change according to it. We are not going so deep into it. For example, I am going to add tag to the bucket. After it is done, click on next button to move further to set permissions. In permission I am not going to add anything. You can add permission for the IAM users. I am logged into as root user. You can give permissions to the other users. I will not do anything into it and click on next to the summary. In summary you can see all the settings that you provided for your bucket. If you need, you can make changes to it also. It's fine for now, and I will click on create bucket. Now our bucket has been created. You can see it on the dashboard. Now we need to add objects to it and see how can access it. So I will click on the bucket link and it will take me to add some objects or file to it. I will add our company logo to it. Let me select it from my computer. Here we go. I have selected a 20.png file and click on upload button. You can also set permissions and properties by clicking on next. But I will click on upload. Now our file has been uploaded to bucket. When you click on the file name, you can see the properties of the file. And there is a link to the file that looks like a DNS URL. This is a unique path to the file. Let's click on it. You will get an error page, because your file is in private mode. By default any file that is uploaded is private. You have to make it public. So let's go back to file and click on checkbox, and in option there is an option to make it public. Click on that option, it will give you a warning of making file public. Go ahead and make it public. Now go to the link again. Now you can see your file. Now you can see your bucket and file permissions and properties. This will help you to manage your bucket and files in it. You can make changes according to your requirement. How you want to give permissions to use your bucket, or you want to use your bucket for website hosting resource. You can use S3 buckets in many ways. S3 is the very old and most popular storage service. Now we will see how to set lifecycle rule and add tag to the bucket. Go to Management tab, there you will find Add Lifecycle button. Click Click on it and add lifecycle rule. You can give any name to the rule, as I gave rule1, and next to it is tag. You can add tag to your object. You can give maximum 10 tags to an object. Once given the tag, hit next. It will take you to the transition. Here you can set transition to the objects of the bucket. Here I am giving, if any object is uploaded after 30 days it will be sent to S3IA, and after 60 days it will be sent to Glacier. You can add any number of days, but for S3IA it should be not less than 30 days, and for Glacier it should be not less than 60. Once done, hit next. Then you can add expiration of objects from the bucket. You can set number of days after your data is automatically deletes from the bucket. You can choose current transition rule, or you can create a new transition rule for expiration. Once you have completed it, hit on review button and it will show a review of the changes that you have created. If all is fine, hit on save button. Now your lifecycle rule has been created. Refresh the page, you can see it. By default it is enabled, you can disable it, may make change anytime. You can also delete it. Now we will see how to replicate your current bucket to the different edge locations with the same rule. In the Management tab, there is one more option, replication. Click on it. You can see a new dashboard is visible on your screen. From here you can create a replica of your bucket to different location. Currently my bucket is in Mumbai and now I want my new bucket to be in Seoul. You have to give unique name to your replica bucket. Now you have to provide destination for your new bucket. Give name and bucket location to it and hit next. On next option you have to provide IAM role to the bucket. After providing IAM role, hit next. Here is review of what you have made rule for replication. You can make change if you want to do. Currently it's fine, so I will save it. Now on the replication dashboard you can see the replication rule. In the same way you can manage other options as well.
Alright, this was all about our session on storage. Hope you all had a great session. Thanks for listening. Stay connected for our next session on VPC, Virtual Private Cloud.